Okay, this lesson is on the atomic theory and the people involved who helped came up with the idea of the atom. So the first scientist who came up with this idea was Democritus, and he came up with the idea of the atom without experimentation. He just used logical thinking. The word atom comes from the Greek word atomos, which is Greek for indivisible, meaning that an atom is the smallest piece of matter. You can't divide it into smaller pieces. He also said that everything in the universe is made up of atoms. So his model, he just said that everything was made up of small atoms, and he didn't have anything more specific about it. So his model looked just like this. The next person was John Dalton, and he is known as the father of the atom. Because he came up with the first atomic theory. So in his theory, he said that each element is composed of atoms. He said atoms of an element are identical. He said that different atoms have different characteristics. He said that atoms combine in whole number ratios to form compounds, so you can't form a compound with half of an atom, they have to be whole number ratios. He said that chemical reactions occur due to separating and rejoining of atoms. And the last part of his atomic theory was that atoms of one element cannot change into another element. He came up with the atomic theory, but his model was still like Democritus, where it was just a ball. The next scientist was J.J. Thomson, and he identified the electron and the proton. That is what he is known for. He discovered electrons using a cathode ray tube and magnets, and I will show you a video of that when we are in class. And he concluded that the electron was negatively charged and the proton was positively charged. He came up with a model called the plum pudding model. And so what he said was that the atom was like pudding, like plum pudding, which sounds kind of gross to me. But it was just like a bunch of pudding, and inside the pudding there were raisins. Interspersed throughout the pudding. And so this is what he thought an atom looked like. Because he discovered that there was negatively charged electrons and that the proton was positively charged, he considered the pudding, this part, to be the positive stuff. So it's positive, this is the pudding. And the little raisiny plums right here are the negatively charged electrons. These are his plums, which represent electrons. Alright, so he was the first one to come up with the idea of the electron and the proton, and also that the atom looked like plum pudding. The next scientist was Ernest Rutherford, and he discovered the nucleus. He experimented by using alpha radiation and gold foil, and that is something that we will demonstrate in class. He declared that the nucleus is a dense, positive core in the center of the atom, and that electrons move around the nucleus. He also was the first person to come up with the idea that atom is made of mostly empty space. And so his model looked like a positive core that was dense, and that this is the nucleus. So it has a positive charge. And he said that the electrons move around it. And so those would be, what I just drew is the path of the electron. And I'm going to draw pink electrons. So his idea was that the whole atom, this whole thing, was mostly empty. The only part that was dense was that middle nucleus, which has a positive charge, and then the electrons move around the nucleus in the empty space. Our next scientist was Niels Bohr. He developed the Bohr model of the atom. The Bohr model showed that electrons move around the nucleus in fixed circular orbitals. And so his was similar to Rutherford's. It still has a dense core, which is positively charged. But this one said that it was almost like racetracks. Some people call this or know this as the racetrack model. And what I just drew were considered the fixed circular orbitals. And so this is like electron orbital 1, electron orbital 2, electron orbital 3. So like I said, this was also known as the racetrack model. The next scientist is Erwin Schrödinger. He came up with a theory of quantum mechanics. He described electrons as a wave function, so not perfectly circular orbitals, but more like a wave. And he assigned quantum numbers S, P, D, and F to every electron in an atom. And so when we talk more about the periodic table, we'll talk about what that S, P, D, and F mean. But he is the one who first came up with this idea. His model was more like the positive core, and the wave function was more like that. And so they weren't fixed circular orbitals, but they moved more like a wave. And our last scientist is James Chadwick. He identified the neutron. And he discovered, or he said, that the neutron has no charge. He said that the neutron is found in the nucleus, and it has mass. This was a huge discovery. So they knew that the proton had mass, and they could see how much the nucleus weighed, but they did not know where the missing mass was. All right. So his model had, let's see, the nucleus was dense, but it was made of protons and neutrons. And then we have the energy levels that the electrons are traveling on. I'll draw pink electrons again. So those are in the energy levels. And the nucleus that I drew, the gray, let's say, is protons. And the black are neutrons. And so he said that that dense core was made of protons and neutrons. Both of those have mass. And then the electrons travel in that empty space around the nucleus. Something interesting is that this discovery and this model was made in 1932, which sounds like a long time ago, but that's actually a few years after my grandma was born. And so this model and this information is relatively new if you think about the history of everything. And so it was only, you know, my grandma, when she was in school, she wasn't learning about this yet because it was such a new discovery. So just something a little bit interesting. Okay, those are all of your scientists.